Thank you for welcoming me to your local meetup. I was asked to talk for 15 minutes, and I'll try very hard to do that, to leave time also for your questions and answers. And because one of the biggest topics right now, and really for the next decade or more in C++ is reflection, there's just nothing like it, I decided, well, let me try to give a short excerpt of the key parts of the talk I gave last month at CPPCon about that. The entire 90-minute talk was about reflection with lots of live demos. I'll still have Godbolt links that you can look at, but I'll try to condense and summarize just some of the key things that are really motivating why this is such a big deal. And the goal here is not for any one example to stay in your minds and say, oh, that's the example I need to know. No, it's to see just how many examples there are that do different things to give us a sense of the breadth of power that's available in this new facility. So in a nutshell, what's reflection? Well, reflection in other languages and now also in C++ is the idea that the program can see itself and generate itself. So it really is meta programming. It's programming the program. And we're having just the first parts of that in sort of version 1 of reflection in C++ 26, which is mostly about reading the program, everything except function bodies, basically. And then a little bit of being able to generate more of the program, but both of those things are going to continue increasing. The main difference with other reflection languages that you may be familiar with, the commercially important ones to date, are mostly dynamic reflection. Yes, there are a few others that are not in the top 10 languages that do have static reflection, but the big difference with C++ is it's all compile time. And if that worries you, that's natural, but there's a slide at the end about why you should not be worried about that. But the basic idea is everything that reflection and generation do is at compile time. But if you need to store any information, you can do that. We have helpers like define static array, define static string, and there'll be more of those to say, okay, save some information for normal program time, program execution time. The nice thing about that is by default, there is zero runtime overhead to everything we can do with reflection. So let me just give a taste of what is possible. And you'll notice that there are Godbolt links to most of these things I'm going to show you. And I'm going to go through them fairly quickly because the idea is to get sort of the flavor for them. And I will provide these slides to Hannah so that you will have them and you can look in detail and at the Godbolt links to see what the code does and also try tweaking it yourself. So the main thing is we've always had the range-based for loop. And we can go for each element in a vector, for example. Well, now, by sprinkling a couple of extra keywords, we can say for each data member of, and the double hat is the reflection operator, is the reflection of whatever this type is. And so I can actually iterate now over the members of a type. The member functions of a type. I can print their names, their types, return types, function signatures, parameters, all of those kinds of things. And it's very similar to what we already do in C++. It's just now we can for each over parts of the program itself. But it's still just C++ code. And here's another example from Dan Katz. So Dan Katz, on the way home from the Sofia meeting in June on the plane, put together this example. So thank you, Dan. And just to give you a warm-up for what's possible in using, for instance, the embed feature, #embed, which says, let's take this JSON file, which I want to be a separate file because maybe I want to reuse that as the source of truth separately in my GitHub repo so that other parts of my program can use this same source of truth. I'm not going to cut and paste it, but I'm going to bring it in as if it was literally inside the C++ source code here. And then I can use reflection, and this is about 200 lines of code or 150 lines of code that you can see at this Godbolt link, where I can now look at this JSON data that's in my const expr array of characters. I can iterate over it and discover its structure. So I can discover that it has two top-level elements, a string, a named magic that has a certain value, and a nested struct called inner that inside it has two members, one of which is word, which is a string, and one of which is number, is an integer. And what this lets me do, this compile time code, which is legal C++ 26, will actually let me generate a structure on the fly that I did not write by hand in my program, where I can say v.magic. Notice that name is the same as the string name in the JSON file. v.inner.word is the same as inner and word. And I've just generated this structure on the fly, and I can make this work. That gives you a sense of what I'm able to do. Even in C++ 26, where I said mostly it's reading, it's reflecting, not so much generating, we can still find ways to generate some things, including to generate some structs on the fly. This is one example of that. And then the splice operator, you'll see the splice operator here, which is square bracket colon, colon square bracket, says, and put the result here of this computation, this compile time computation, put the result here as if I had written it by hand in source code. That's basically what splice does. We're going to see splice again later on, because we actually use that more. But I want to focus on one. I'm going to skip a few examples, though, that show more splicing and go to a bigger example. So I thought, well, how can I show doing something maybe more interesting? And type erasure is something we like to do in C++. So what I started doing, and I'm doing this deliberately not using reflection to show you how you can migrate code, how you can figure out the reflection code as you write the reflection code to generalize things that you can already write by hand today. So this slide is pure C++ 20. It's C++ 23. There is nothing major going on here. So I want to write a drawable type erased wrapper that can wrap any object that has a function compatible with this signature, including conversions on the parameter and return types, just like std function. So I asked, because I'm not an expert in that, and because, well, this is a mechanical thing that many have done before, I'll bet an AI can do most of this for me. So I asked ChatGPT, and it generated quite a bit of code, which I then tweaked into my style and also generalized in a few ways to make it the way I wanted it to be. But thank you, ChatGPT, for doing the grunt work for that. But it was about 200 lines of code. But what it let me do is I can have now a vector of drawable. Drawable is type erased, but it's also a value type. So down here you can see I'm copying a drawable and so forth. But what it does is it can wrap an object of any type. So I can place back a sprite or an icon or a button. And as you'll see in this Godbolt link, those are all unrelated types. There's no inheritance going on. There's no a priori knowledge that these things are drawable. The only thing they have in common is that they have a function signature compatible with that. So Sprite, I believe, has one that's exactly this. Icon has one that returns not an int, but something that can be converted to an int. And button takes a point type, which is convertible to a coordinate. So I get that flexibility, but I can treat them in a type erased way consistently, so I can now for each over every element in this vector and invoke the draw function, which is compatible with the signature but slightly different in each of these concrete types, and it works. And you will see when you run that program, that's fine. This is not magic. This is not new. You can do this in C++ 20. I don't even think you need anything in C++ 23 to do that. 200 lines of code. In fact, this is what the lines of code look like. So far, I've written this by hand. Now I want to make this generic. So what I did is I took exactly that code. I said, this is what I want to generate. And what I did is I cut and pasted it into a const expr function, basically, and put quotes around all of that. I said, I want to generate all this code. So I took the code I wrote by hand, put quotes around everything, so it's now strings that I output. And any place I saw the word drawable, I just plugged in the name of the name of the type I'm being instantiated with to copy its interface. So I've generalized this to now where I can just provide drawable as a prototype, as an exemplar class, say, hey, create me a type erased, use this poly function, create me a type erased wrapper with the same name as this. So that's the word drawable is. It's now input, and that has the same a compatible function signature, and it generates all of that same code, and it just works. But now I've written something that isn't hardwired to just drawable. I can now create another class that's invocable, or I can create another class that's printable, that has one or more functions. It doesn't have to be just one function. It can be any number of functions. And now when I create this type erase class that generates its own vtable on the fly, I generate extra vtable entries, the right number of vtable entries for all the functions I've been given. And now I've written this type erasure one time forever, and I can just use it. And of course now, because it's just code, we can compete on who writes the best type erased code. But we're going to have just a small number of those. We're going to use them forever and never have to write them by hand again. So that's another example of using reflection. One big example that I've been showing for 8 years now is using reflection to author classes, and we're getting part of that ability in C++26. So I would like a world where I can declare that I'm not just writing any class, I'm writing an interface class, a proxy class, a value class, a JSON serializable class, anything I want to say, and with commas, put in more than one thing. But I'm declaring this kind of class, and that affects the defaults and generated functions of what I print in the body. So I just show, hey, look, I've got an int f function, a void g string function, and I want those, in this case, for interface, to be pure virtual by default, public by default. I want to generate all of this code on the left. And as you will see, in this Godbolt example, I can get most of the way there in C++26. What I do is I use this trick of putting the class I'm writing, which is exactly the same way without the decorations, the way I wrote it here on the right-hand side. And then I run an interface as a const eval function. And that const eval function now will generate all this code exactly as I wanted it. Now, the one limitation in C++26 is I can do all of this work, but I have to generate the results in a separate file, which I can then integrate with my build process to use that in the same build in my program in other files, but not yet in the same file. Post C++26, we're going to be looking at adding the ability to generate new code right in this file as we are compiling it. And then that syntax that I showed, which has been provisionally approved by the compile time programming group in the standards committee, this is just a syntactic sugar for this pattern. That's all it is, but it's a powerful syntactic sugar so that I can say, hey, I'm not just authoring a class, I'm authoring an interface, a proxy, a traits type, a widget, an async class, and many, many more things. All of these are just to give a few flavors of the things we can do. And I showed more in the longer talk at CPPCon, and we went into more detail on some of these examples. But now I want to start just pulling together some ideas and takeaways. This is going to really help us simplify C++ evolution and also C++ as we use it. But we're going to need to add fewer special purpose language features in the future, which is a good thing. Now, reflection won't do everything, but many, not all, many new language features could instead be done well as compile time libraries. And we already have proofs of concept of many of those things. Well means the same usability, the same flexibility, the same efficiency, performance. And there's benefits to doing that. If I don't have to hardwire a feature in the language, I don't have to wait for the compiler vendor to implement it and wait for it in GCC version next or Clang version next. Because it's code, I can test it. It'll work on every compiler right away. I can deliver it anywhere I want in GitHub, package managers. I can adapt it and fork it. It's just code. I can do everything that I want with it. So what are the things that we can do? The answer is we don't know yet. It's going to take us 10 years to figure out all the things we can do with reflection in C++26 and the further things that are coming to be added to it. But here's just a starter list just to get our imagination going so that together, all of us, we can actually think about what are these things? What should we be thinking about? What can I do now? Well, we already mentioned create a JSON serializer, deserializer for any C++ type, or because you can iterate over all the types in a namespace, you can easily write a const eval function with just a few lines more that says iterate over every type in this namespace and generate a serializer, deserializer for it, JSON. You can also generate not just C++ code, but Python code, JavaScript code. I go into examples of that in the talk that you can find on YouTube. It's linked to from my blog, herbsutter.com, where you can generate code bindings to other languages. And I go into more detail at the end of the CPPCon talk about why that's potentially game-changing in our industry, but it's useful just for C++ developers. We can generate binary files such as that Qt or C++ WinRT needs on Windows to have types be usable by the operating system or by environments such as the Qt runtime. We can just do simple things like say, hey, let's automate the array of structs to structive arrays optimization, which is very important for compute and for making use of prefetchers. We can decide to customize a class's object layout. For example, what if I want a class that has no padding? And, well, you can generate that if that's what you want. Or just that sorts its members in order from the greatest to lowest alignment, that kind of thing. What if I want to go through every function in a namespace and all the ones that are flagged as unit tests, create a unit test function that invokes them all? Easy to do. What if I wanted to write a class that's asynchronous, where every member function call gets put to a thread pool and you run one at a time, so the class is internally synchronized, but you take a C++26 thread pool, a sender-receiver thread pool, and you run each member function over there, and because you return right away, you're launching that and returning right away. Instead of the return type, you return a future of that same return type. All of this you can automate and write in portable, testable, shareable standard C++ code without the language extensions and side compilers we need today. And because I thought that the mind-blown emoji was almost right, but not quite right, because yes, this is mind-blowing, I think, at least it is to me. But the mouth on that standard iOS mind-blown emoji looks a little too sad or afraid, and that's not my reaction to this at all. So I asked ChatGPT to fix it. Thank you, ChatGPT, for fixing it. I think that is the correct mind-blown emoji for what is in store for us. So wrapping up, the key to remember, as you're thinking about what can I write using reflection, if you can write the code by hand, you can generate it. That's the principle. And we're going to be supporting more and more of reading and writing everything that you could read and write as a programmer, reading the code and writing it. So think of it as a way to facilitate automating writing source code, except you're in control. You're not asking an AI to do it. You're actually writing a script to generate the code, but not by hand. You're now able to generalize in a new direction. So what would you do if you had the equivalent of an accurate, always up-to-date C++ parser? Well, we're about to find out, because everybody is going to start doing this. And I mentioned at the beginning that you might be concerned about all this work being done at compile time. We are going to see a huge, huge explosion in C++ compile time code, but I believe not in C++ compile time, because in many cases, not all, but many cases, it's going to make C++ compilation net faster. How is that possible? Because we're going to be replacing, at least at first, the slower things we do today. Template metaprogramming. We already have been converting a lot of template metaprogramming to const expr code. And I don't know if you've noticed this, but when you take a template metaprogram, which is expressed indirectly, a computation expressed indirectly through a template type system that it's a type system. It was never designed to compute anything. But you use the computation as a side effect because it happens to be Turing complete. When you convert that code to directly expressed context per code, it's very often an order of magnitude faster already today. Why? Because we're directly expressing our intent. Because we're saying, here's what we're doing directly, not indirectly. And I'm going to embarrass Hannah now. Hi, Hannah. When we voted this into the standard, now 4 months ago, in Sofia in June, Dan Katz went to Hannah partway through the meeting saying, yes, it's going to work. We're going to finish the wording review, and we're going to have the poll on Saturday to add reflection to C++26 this week. And Hannah's answer was perfect because, as many of you know her personally and have seen her in action, she's very quiet, reserved, says a lot with few words calmly. And her response was exactly what we should all keep in mind for the next decade, to understand today how pivotal this is. She gave a little shrug and deadpan said, whole new language. Exactly. That is exactly what we have in front of us. So that's an excerpt of the talk. You can try those Godbolt links yourself. I'll provide these slides to Hannah for you to take a look at, but it's also up on YouTube. You can find the link. It's not published on the channel yet at CPPCon channel, but it is on my blog. So just look at herbsutter.com. It's one of the more recent blog posts in September that it was when it was made available, and you can find the YouTube link there for more detail on some of these things. But I'd be happy to answer any questions you have. But most of all, I'm hoping that you're as excited as I am about the possibilities ahead of us. This is not the only major feature in C++26, but it is probably bigger than any 4 C++ standards put together in terms of its impact as one game-changing, important feature. So be excited about reflection, and happy to take any questions that you've got. And I hope I didn't embarrass you too much, Hannah.
Okay, I don't know how to do the questions here. So if you have questions, I will relay them to Herb so he can hear them. So, okay, the question is long, but I'm going to compress it. At first, it was reflection is great in C# and other languages, and the author of the question is asking if there are like any tips how to make the code easier to reason about when you use a lot of reflection.
How to make which code easier to reason about?
The code you write and generate. Because debugging is starting becoming issue because you are now debugging code which doesn't exist, and it's kind of funny.
Okay. Yeah, so one of the issues that we're going to encounter is we will need more compile time debuggers. We already need them for context per code and const eval code. And so one of the things that we're seeing is tools are starting to do that. So the same week as CPPCon, just a few days before, I think, JetBrains announced a context per debugger. And so that's the kind of tooling we will get more of, because we will need to do something with the compile time code we have. As we now generate code, it's going to be super important to see the code. And so it's actually both a weakness and a strength of C++26 reflection. Like I said, today, most of the generation that we're going to be doing is into another file, because we can reflect and then just use standard file I/O to generate. The bad news about that is we can't immediately use it in the same translation unit. We have to use it in another translation unit, but in another source file. But the good news is we can then immediately debug it. We can see it. It's just source code. It's visible and available. So that's going to be something that tools are going to help us more. And by the way, this is one of the reasons why one of the very first metafunctions that I implemented in CPP front is print, to actually reflect over and print what I generated so I can see what I generated. That's very important to do. And print actually gets you a long way.
Okay, maybe we will have microphone now, so people can ask question in person. We have microphone there. By the way, I'm working on context per print for Clang, so you will get it.
Yes, thank you very much. The two things we need, context per print is number one, and number 1.5, right on its heels, is context per file IO, and the O is more important than the I.
Yeah, I have.
So
I have
if you can just give me context per fprintf, and I will be so pleased.
I'm going to give you stats in and stats out.
Even better.
Okay, if there is any question, we have microphone here, so just raise your hand and we will give you microphone. Anyone? Don't be shy. Herb doesn't bite and he's far away. No one? Really? I think I was teleported to Norway because on Norway at conferences people don't ask questions. So if there is a question, so finally, hopefully you will hear it.
So is there any chance that with that reflection we may definitely get rid of the macros in C++?
Spicy.
So reflection is going to help us get rid of some macros. It's yet another step in the journey to freedom from the slavery and tyranny of macros. It will not do everything, but a lot of the things we use, macros and template metaprogramming, our two favorite bugbears to accomplish, will be able to accomplish directly. One of the interesting things, and this is actually going slightly in the other direction, one of the interesting things about generating source code is that you can generate source code that's just ordinary source code, right? Which means it can use macros.
Boo. Any other
Hey,
question?
but sometimes you need to. Let's not judge, right?
Yeah, let's judge. Anyone? Please do ask. Yeah, they are shy. There's another one.
Can you give a hint why generating JavaScript code from C++ is a good idea?
I can answer that.
So-
by the way. Well,
Oh, okay. Hannah, you go first, and then I'll point to the talk.
I'm known like on most of my C++ conferences. I have slide. I allow JavaScript. Now you.
So the main use case I have in mind there that I care about is not so much generating arbitrary JavaScript code from C++. It's not like we're using C++ as the language to write JavaScript in. That's not the idea. The idea is if I have a C++ type, then I want to make it available to another language. Could be Python, could be JavaScript, which includes TypeScript, could be Go, could be anything, even C, right? If I can automatically generate wrappers to be able to use basically use the C++ type natively from another language, then I have a big opportunity, because today's lingua franca, the only language that really any other major language can talk to is C, which means all of our operating systems APIs, all of our interop code between Rust and Go, for example, everything has to go through C, because they can't talk to each other except through C. And what's wrong with C? Okay, I'm going to give away the talk for the longer diatribe and the longer rant. But what's wrong with C? Unencapsulated structs, raw pointers, manual memory management. What could go wrong? And we have had so many attempts. We've had COM, Corba, the CLR. We've had so many attempts to try to make a runtime that's at least a bit higher than C, at least tell it about objects, have encapsulated objects with member functions, at least that. And we haven't been able to do it as a widely used foreign function interface. I think our only hope, if that is ever going to happen in the lifetime of our careers, I think the only reasonable hope, and it may not happen, but it's the only hope we have of it happening, to have operating systems APIs and other APIs where we can say, hey, I can write a rich API that any major language can call directly, and that does talk in encapsulated classes, not raw structs, that does talk in smart pointers, not raw pointers, that talks in high-level memory management, not raw memory management, manual memory management. Our only hope is C++ with reflection to be able to write the C++ types, which are strongly encapsulated, which have member functions, types, all that richness, and expose them natively to all sorts of other languages. Now, is it going to be fast enough at compile time? Well, we compile once. Is it going to be fast enough at runtime? We'll see. But Emscripten and Swig and other efforts already show that this is needed and is being done. PyBind. If we can automate that and say, hey, I want to have my C++ type be available to all other languages, and you can declare it as just class paren API, paren, where API invokes generate Python binding, generate JavaScript binding, generate Go binding, generate C binding, generate Rust binding. And that's all I have to do, say class paren API, paren. That is a huge opportunity. And it's one of those rare times, I think, and again, I am an optimist, but I'm often right. It's a rare opportunity where adding a feature to one programming language can actually benefit many programming languages and the entire industry. It is very rare that you add a feature to C++ or to C or to Python, and it helps Rust or Go or Zig. But I think this is one of those opportunities. We're still going to be spending the rest of the decade, the next decade, finding out all the things we can do with reflection. But I think that's an important one to try. And several people are already trying that kind of direction. So I think we'll see results sooner rather than later. But see actual live demos of that in my CPPCon talk, where I generate such bindings on the fly, including the Python binding I demonstrated. I have the widget class that can be invoked with member functions from Python, including with named arguments. Woohoo. So like that's something that you can make it pretty seamless, and I'm pretty optimistic about that. I think it's our best hope for up-leveling the industry from just naked C APIs as our lingua franca to be able to talk about encapsulated objects, which I think would be a huge improvement for the expressiveness and safety of our APIs that we use to power our civilization.
Okay, we are running out of time. We will have one small question. I will also say someone will write a library which will take reflection and migrate your C++ code in safe JavaScript.
So, hi, I have a short question with a potential for a short answer. I guess you have talked with the compiler implementers. Have they indicated how hard it is for them to implement this? Of course, the question behind is, when can I have it in all the three major compilers?
Yes, that is an excellent question. So I cannot speak for compiler vendors, not even Microsoft, because I no longer work there as of a year ago. So I cannot speak for their product plans. I happen to know that a detailed Clang prototype already exists, and it's about 15,000 lines of code that would need to be upstreamed, and the main blocker is finding someone willing to do that work. But that implementation already exists. Thank you, Dan Katz of Bloomberg and now of Adobe. And I happen to know that GCC has two developers on it, including one who's, I'm told, is somewhat of a superstar, who are working on reflection as we speak. There's two parts to this. I think that it's not as difficult to implement as some other features we've standardized, and I'm not even talking about modules, because modules is unlike anything we've ever done in terms of astronomical costs. So like never compare anything to modules in terms of difficulty. But it's even easier than, say, coroutines and other things like that. But also there's a question of what's the motivation of compiler vendors. And reflection, because it has such high value, is going to be one of the things that compiler vendors should, and as far as I can see, are running, not walking, to go implement, because it's going to really make a difference for their customers. Qt already has a wiki page on planning the migration for Qt mock, to saying, okay, how much of this can we do with reflection to sunset mock? And so there's active industry interest and customer interest. The compiler vendors can see that.
Okay, by the way, the GCC implementation is done by another Czech guy living in Prague, by the way. Czechs are important. Did you check?
Yes.
Okay, we are running out of time. We need to move with another talk. Thank you, Herb, for joining us, and
Yes.
I hope to see you in June here in Brno.
Yes. See you then. Have a good rest of your evening.